All right, let's try to finish up section 1.5. If anybody's watching this on YouTube, it's going to look weird because I'm only using like half my screen because the screen up here is so big. I can only write on half of it so it fits on this board. So that's what it. So if you go and watch it on the YouTube video, you'll see that it looks a little weird, and that's why I did that. So I'm going to try to keep everything. I got to change a couple things here. That's why everything looks a little bit weird. Hopefully I'll get that projector fixed. Let's see. I gotta change that to that. There we go. And I'm gonna change it to 0.5. Then you can read a little bit better. All right, here we go. Let's talk about this word, and it's called midpoint. We're gonna be talking about this word all year long. This is a super important word. Some of the words I tell you that you probably won't see too much of. This is one that you're gonna see a ton of. So let's draw it. This is a line segment, so it doesn't keep on going in both directions. It starts and stops. And let's do this. Let's find out where the middle is. It's right there where that dot was. And I'll put a dot right there. Okay. So this is A, this is B, and yeah, we'll call it C. All right, so we got a line segment. The last thing we talked about yesterday before we did that example with the AC is equal to 75 thing, we just said that B was between A and C. All right, because if you have a point to the left, you got a point to the right, that must mean B is in between them. But this is a little bit more specific. Now, right now, just the way that it's drawn, you can't see anything about it. I mean, you could guess. What do you think might possibly be true about line segment AB and line segment BC? What does it look like? If I was to measure, if I took a ruler and I put it up there, what does it possibly look like AB and BC are? Say, the same. It looks like they're the same, doesn't it? It looks like they're equal to each other. You got a thing on your shoulder. So right now, just looking at it, you cannot just make the assumption that they're equal to each other. All right, you can't just look at it. A lot of people do. They'll look at it. Pretty soon, we're going to be talking about angles. People look at it and say, "Oh, that looks like a 90-degree angle." But if you don't know for a fact that it's 90 degrees, you can't just say. You can't just guess. Same thing with this. It looks like A, B, and BC are equal to each other, but you can't just look at it the way it's drawn right now and say that they are. You can't make any guesses. But they will tell you stuff. They might tell you up in the description, they might say AB is equal to BC. They might tell you that. Or most likely they'll do this. They'll put a little tick mark here, a little tick mark there. We've talked about those tick marks. It means those segments are equal to each other. So if this and this both have a tick mark, now what can you say without a shadow of a doubt? What can you say about AB and BC? Just tell me that they're the same length, exactly. So what does that mean about point B then? Point B is where? It's in the middle, exactly. It's in the middle, all right? So if it's the same distance from A as it is from C, then B must be right in the middle. So guess what special name we give that point that's in the middle? The midpoint, right? That's the midpoint. Sometimes I shorten it, just put PT instead of POINT, but that's the midpoint right there. Okay, so B is the midpoint. What if, let's get rid of all this. What if they told you this? What if they didn't tell you that AB and BC were equal to each other, but they told you that point B is the midpoint? What if they told you that? What else could you tell about this picture right here? John? Well, you got 3 points just by looking at it, but just by looking at it, we didn't know what was true about B, but now we do because they tell you that B is the midpoint. If B is the midpoint right here, what does that tell you about line segments AB and line segments BC? That they're equal to each other. That's right. You see the difference? The first time I told you the line segments were equal, that means that B is the midpoint. This time I said that, okay, I don't know anything else, but I do know that B is the midpoint. So if B is the midpoint, that must mean that AB is equal to BC, or the length of AB. Remember, if there's no line over top of it, it means the length of AB is equal to the length of BC. Or you could do this. What if I put a little line segment over top of it? What would I have to change this to? Not equals, but, yeah, and what is the word? Congruent. Very good. Okay, yeah, you put the little squiggle on top, right? So when you put a line segment, you say they're congruent. If you don't put a line segment, it means the length of AB is equal to the length of BC, because the length of something indicates a number. So I can say that numbers are equal to each other. I can't say that line segments are equal to each other. Does that make any sense? It's a subtle difference, but if I had a line segment here and a line segment here, if they're the same length, you could say the lengths are equal, but are they the same exact line segment? No, because this line segment's sitting over here, this line segment's sitting over there. They're not the same exact line segments, so they're not equal to each other, but they are what? Congruent to each other. You got it? Again, it's a weird, it's a subtle thing. Hold on. Okay. It's a subtle thing, but that's it's something that's important to know. All right, enough of that. Now, we are going to get into something a little bit different now. It's the same section. Let's get rid of all this. It's the same section, but we're going to talk about angles now. I don't think we've talked about angles at all, have we? Okay, we're going to talk about angles. We did talk about angles because we talked about two rays, didn't we? Two rays that have a common endpoint. Yeah, we said it's an angle. But what we're going to do right now is we are going to talk about some special angles. Okay, so some special angles. So if let me say this. We measure angles in degrees, all right? So whatever the slant is. So let's take these two markers. If I had a slant like this, I actually have something that can measure the degrees. Do you know what that thing is that I can measure the degrees? If I wanted to physically find out what that angle is right there. It's not a ruler. A ruler tells us the length of something. It's a protractor. That's exactly right. So if I had a protractor, which I do, but I'm not going to get it out. But if I had a protractor, I could take these two pens that I'm holding up right here, and I could measure the degree between them. Everybody see that? Now, that degree could change, couldn't it? It could go like this. It could go like this. It could go like this. Okay, it's on a hinge, like this. Okay, so I could measure that in degrees. What if I went all the way around to where I started? You should know this. How many degrees is that? It's 360, right? So basically what we're doing is we're taking the whole circle, 360 degrees, and we're breaking it down into 360 1-degree little arcs. Okay, so here's what it is. Let's say you had one like this and like this. All right. Actually, let's hold on to that just for a second. Let me do something else before I get to that. I did this in the other class, and I think this might explain it a little bit better. We talked about that 360 thing. All right. So watch. 360. If I started, let's do a different color with this. Let's everybody watch. From here, if I started here, and usually, remember in Algebra 1, this is the x-axis, and the up and down is the y-axis. Do you remember that? Okay, and this is the positive x-axis. So when we measure degrees in geometry, we always start from the positive x-axis, and we always go this way. Is this way clockwise or counterclockwise? It's counterclockwise, okay? It won't be long before nobody will have an idea what that even means clockwise, okay? Because a lot of you guys probably don't even, because I've had a couple people come in here, they say, what time is it? I said, the clock's right there. And they're like, oh, I can't read that thing. All right, because, and it's, I can't really blame you. You're not to blame, all right? It's because teachers don't teach that stuff, I think, anymore, because everything's digital all the time, right? So barely anybody looks at a clock. But a clock, right, 12 is here, and then 3, and then 6, and then 9. But if you go this way, you're going the opposite way that the clock goes. You're going the opposite way that the clock goes, so you're going counterclockwise. So if this is 360 degrees all the way around, right? If I go all the way around, that's 360 degrees. Well, if I go to here, if I just go to here, what fraction of that whole entire thing is this? What fraction? 1/4, okay? And what's 1/4 of 360 degrees? What's 360 divided by 4? What's 36 divided by 4? So what's 360 divided by 4? It's 90. So this angle right here is 90 degrees. Everybody see that? So from here, watch, I'll just draw it. From here to here, that's 90 degrees. Okay, what is it to here then? Right here, this spot. To here. How many degrees is it? T-O-H-E-R-E. To here. It's 180. Because each of these blocks right there is how many degrees? It's 90. So that's 90. That's 90. This is 90. So how many degrees is it down here? 270. And then back up to what? 360. Okay? Notice I put the degree symbol. That's how we measure these things. We measure it in degrees. All right, with that said, let's get rid of all this. Look at this angle right here. Is this angle 90? Is it more than 90? Is it less than 90? What do you think it is? That's 90 degrees? Look at what 90 looks like. Look at 90. It's straight up, straight across. Does that go straight up compared to this?
Yes, that's a 45 degree.
Well, we don't know if it's 45, but we do know it's less than 90, don't we? Because it lies somewhere in here. See?
It's like 50, 90.
It lies in here somewhere. 90 degrees, it's straight, right? If this one goes across horizontally, this one goes vertically, that's 90 degrees. This is less than 90 degrees, right? 90 degrees, right, straight up, straight across, that's 90 degrees. That angle is what? Like this. It could be 45, all right, but we don't know for sure. But we do know, just by looking at it, that it's what? Less than 90, right? So it's less than 90. And we have a special name for that, okay? So I'm going to write less. It's less than 90 degrees. So any angle that's less than 90 degrees has a special name. These are special angles. That's right. We call it an acute angle. And I'll put the symbol for angle. Did I show you the symbol for angle the other day? I think I did. Yeah. So this is called an acute angle. Why? Because it's less than 90 degrees. Okay, let's do another one. Let's do a right angle one. And I'm going to show you something that we haven't talked about yet. It's pretty important. All right. So what does that look like? Yeah, it looks like it's 90 degrees, but you got to be very careful. Everybody listen to me now. You got to be very careful. Just because it looks like 90 does not mean it's 90. It could be 90.00001. Would you be able to tell the difference by looking at it? No, there's no way. It could be 89.99999. Again, you wouldn't be able to tell the difference just by looking at it. So how in the world would I be able to tell if that's 90 degrees or not? Well, they put a little symbol. No, they put a little symbol right there. They put a little box in the corner. If they put a little box in that corner right there, that automatically means it's 90 degrees. So I can say without a shadow of a doubt that that thing is 90 degrees. Okay? Now, you could also, it doesn't have to be horizontal and vertical like I said earlier. Oops. Did that change the degree of that angle? Still 90 degrees, isn't it? It's still 90 degrees, even though it's slanted up and like this, okay? It could be. So let's do another word. So this is equal, we should have put that in blue, equal to 90 degrees, and give me a second. I don't know, it's not that important, but I want to keep consistent with the other one, so that's blue. All right, so if it's equal to 90 degrees, we have a special name for that. If it's less than 90, we call it acute. If it's equal to 90, we call it a right angle. That's right. We call it, hey, I give her credit for at least trying. So it's a right angle. We call it a right angle. So 90 degrees is a right angle. Everybody with me? All right. So let's scooch this back down. About right there. All right, let's do another one. So what if you had an angle like this? That's 180. Sure about that?
No, it's like up to like
Let's compare it to 90. Let's compare it to 90. Is it less than 90?
more.
Is it equal to 90? It's what? It's over 90. It's more than 90. It's greater than 90. So let's use that word. Let's use the word greater. I was going to do this in blue. Let's do
That's
this in
probably
blue.
like 145 degrees.
Yeah, we don't know. We'd have to measure it. But we definitely know it's bigger than 90. It's greater than 90 degrees. So if you have an angle that's bigger than 90 degrees, we have a special name for that. Anybody know that? Yeah, I heard it. It's obtuse. Very good. All right. Obtuse can be used for several different things. Like if you wanted to be like real smart and tell somebody and like what's the word? Not criticize, but if you want to put somebody down, right, without them knowing, you could say, man, you are so obtuse. So obtuse kind of means you really don't know what's going on. You don't know what's with it. You're not that bright, okay, kind of thing. It's probably not you're not that bright. You just don't know what's going on. You're so obtuse. So if you say that to somebody might think it's a compliment. Who knows? All right, but if you told somebody that they are obtuse, normally that is not a compliment to somebody. All right, not trying to tell you how to belittle people, but that's what obtuse is. But in our case, an obtuse angle is an angle that's bigger than 90 degrees. Yeah. You got your book?
I still haven't.
Well, you need to get one. Let's see. There's one more. There's one more to do. A lot of times we don't think about this as being an angle, but I'll show you that it is an angle. What does that look like right now? It just looks like a straight line, doesn't it? Especially if you put arrows on there. But I put a dot right there. Okay? So basically we have two rays, don't we? We have two rays at a common endpoint. What did we describe as two rays with a common endpoint? It's a what? It's an angle, right? So this is actually an angle. There are two rays with a common endpoint. Are you going to be able to handle sitting there? I let you sit there, but this is your seat. It's not cool with me because you're talking. So this is two rays with a common endpoint. And so this is an angle. Okay? How many degrees, first of all, do you think this angle is? Or do you think it's more or less than something else? It's exactly 180 degrees. All right? It's exactly 180 degrees. So a straight line is 180 degrees. All right? So this is equal to, write it down, equal to 180 degrees. I don't know why it matters, but I want to keep this color coordinated, so I'll change it back to blue. All right, it's equal to 180 degrees, and we have a name for that. So what does it look like? It looks like a straight line, doesn't it? Yeah. All right, but it's an angle. So what do you think we're going to call the angle? I gave you huge hints here. Looks like a straight line. Ty, sit up, please.
Oh.
Get your head up off the desk. So it looks like a straight line.
Line L.
It looks. Listen to me. I'm giving you huge hints here. Take my hints. Everybody listening? Looks like a straight line, doesn't it? Straight line. But it is an angle. So what kind of angle? Clay, what do you think? It's a straight angle, exactly. All right? It's a straight angle. Because these are special angles. Remember before at the top of your notes, it says special angles. So this is a certain angle. It's a straight angle. So where is the bend? It's right here. Okay, it's 180 degrees. I've heard people, sometimes even preachers, listen to this. I've heard preachers say, you need to turn from your wicked ways. You know, back in the old days, they used to preach like that, right? Turn from your wicked ways, and you need to turn to Christ and turn from the devil. You need to turn. Listen, why are you talking when I'm up here talking? I don't understand. I'm telling you a story. Listen to my story and stop talking. So I've heard different people, whether it could be politicians, it could be preachers, it could be people, and I've heard them say, you need to turn from your wicked ways. You need to turn 360 degrees and follow Christ. Well, if you were following the devil and your wicked ways, Is turning 360 degrees turning to Christ? No. How many degrees would you turn if you're going to turn from your wicked ways? 180. Now, I'm sure that they knew what it was, but they probably just were thinking numbers and they thought 360. But if you turn 360, that means you're going the same way that you're going before. All right? So they would say if you're going to turn from your ways, you're turning 180 degrees in the exact opposite direction. So that's what 180 is. All right? Let's do some more. There's a lot of definitions, but these are definitions and words that we're going to use a lot. So what if I had two lines that did this? Judah, right here. I already warned you once. Come back here and sit. This is your regular seat anyway. Your next seat's going to be in Mr. Sarek's office. I don't know what's so difficult. I think it's your training. I think other schools never made you sit and listen. But I'm going to. By the time you're done here, you're going to be trained and you're going to learn to sit and pay attention and take notes. All right? Here we go. What if we had a situation like this? What kind of an angle do we have here? We have a right angle, which is how many degrees? Which is 90 degrees, okay? If I have two lines that form a right angle, we have a word that describes those two lines. And we say that those two lines are perpendicular. You've probably heard that before. Maybe even in football. Did you ever hear that word in football? All right? Like a running back. Okay, running back, if you run perpendicular to the line of scrimmage, how are you running? You're running sideways? That wouldn't be perpendicular. Straight. Okay, you're running straight through the gap. Okay, you're running straight through the line. All right. So if this is the offensive line, and here's your running back, if they said run perpendicular to the line, what are they asking you to do? Run in this direction, perpendicular to the line. Okay. Everybody see that? We're going to learn another word, not today, I don't think, but is parallel. What if you ran parallel to the line of scrimmage? Are you going to gain much yardage if you run parallel to the line of scrimmage? No. Okay. Not if you run parallel. Doesn't matter how good you are. Okay. If you run parallel, you're not going to gain any yards at all. Okay. You're just going. You're not going in any direction. You will lose yards. All right. Enough of that. We have a symbol for perpendicular. All right, and it kind of looks like this. This is the symbol for perpendicular right there. So if I wanted to talk about these two lines, talk about AB and CD. So line AB, if I wanted to write line AB is perpendicular to line CD, this is how I would write it. Line AB, you got to put the arrows on there, is perpendicular to, put the perpendicular symbol that we just learned, perpendicular to line CD. That's how you would write it. I don't know if it's a quiz question or not, but if I did ask, to write this situation, this is how you'd write it. Line AB is perpendicular to line CD. If I just gave you this and I asked you to draw a picture that illustrates it, then this is what you would draw. You would draw the blue thing. Everybody with me on that? Pretty simple. Just forms a right angle. What if I didn't have the box there? Do I know that those two lines are perpendicular? Without them telling you. Just the picture, just the blue. If that's the only thing, could I say that those lines are perpendicular? Yeah. Come on, we just had to talk on this.
No.
Why?
Because the right angle.
That's right. The right angle symbol is not there. There's nobody to tell you that that's a right angle. Okay? If all you have is that blue, forget the yellow. If all you have is that blue, there's no way that you could tell that they're perpendicular. Do they look like they're perpendicular? Yeah, they do. Absolutely. That doesn't mean that they're perpendicular. Just because it looks like it, it doesn't mean it's perpendicular. You have to be told. And this is something that's very important to get through, because a lot of students, they just look at stuff and say, oh yeah, that looks perpendicular. But it may not be. But if they put the box there, that little box right there, means it's a right angle, so that means that they are perpendicular. So yes, now I could absolutely say that those two lines are perpendicular. Okay? Let's continue. Let's do another word. We've already used this word. Actually, we've used both of these words, but we haven't put them together yet. Congruent angles. Okay? So we've used both of the words separately, but we just haven't put them together yet. So let me show you an example of congruent angles. Basically, congruent angles are two angles that have the same measurement. Okay, so whatever the angle degree is, I don't know, let's say it's 40 degrees. I'm just making that up. I have no idea what it is. Let's say it's 40 degrees. If I draw another angle at 40 degrees, what's true about those two angles? They would be what? They would be what? They would be congruent angles. Okay, so let me move this here. And they don't have to be facing the same way. Okay, let me twist it around a little bit like this. And let me show you how we show that angles are congruent. Do you remember the little tick marks to show that the two segments are equal to each other? Angles have the same kind of thing, but we don't use tick marks. We use these little arcs right here. If I put one arc right there, and I put one arc right there, tell me something about angle A and angle B. If angle A has one arc, angle B has one arc, what do you think that means about those two angles? That they are what to each other? That they're the same measurement, right? So that must mean if they're the same measurement, then they are what kind of angles? Congruent angles, right? So what if I did this? And this is kind of stuff you might see on your homework, all right? Very similar. So what if I said that angle right there is 30 degrees? This has one arc, this has one arc. So without me saying anything else, what can you determine about angle B? It's also 30 degrees. How do you know? Because they both have the one arc. Everybody with me? All right, so you know that that must be 30 degrees as well because they both have one arc. Let me do this. What if you did this, but you took this angle, and let's just change it just slightly, like this. Okay? Now, I definitely changed that angle, right? I don't know it's 90 degrees. It looks a little less than 90 degrees. But watch. What if I wanted to show that this angle was not equal to this angle? So these two angles have one arc. Watch what I'm going to do to show that this is not equal to this. I'm not going to put one arc, because if I put one arc, what does that mean? It means they're the same, right? But if I put two arcs, that means that this angle is different than this one. Everybody see that? If I had another angle that looked just like this one right here, and it had two arcs, then they would be congruent, right? So only the ones with the same number of arcs on them are congruent to each other. So I don't have to put just one arc. I could put two of them if I want to. I could put three of them if I wanted to. All right, so that's really important. You're going to be seeing that kind of stuff all year. All right, so make sure you understand what's going on here. So I could, tell you what, let's just move this over a little bit, and let's copy and paste this. Actually, let's do this. I didn't paste it, sorry. There we go. Now let's copy that and paste that. That's what I wanted. All right, so let's put this up here. Let's twist it a little bit just to make it look a little different. And so there we go. So what if I called this C and D? Angle C and D. So just by the marks, forget the 30. Let's get rid of that. Let's get rid of that. Let's get rid of this angle degree symbol. All right, just by looking at them right here, you should be able to tell which ones are equal to each other. All right, A and B are equal to each other. Why? How do you know they're equal? Because the one arc. How do you know that C and D are equal to each other? Because they have two arcs. All right, so the ones with two arcs are equal. The ones with one arc are equal. Make sense? I promise you're going to be seeing this not every day, but really throughout the whole entire school year, you're going to be seeing this. All right, so make sure that you understand what that means. That's the first time we've talked about it. Definitely won't be the last time. One more thing and we'll be done. No. You only got 5 minutes left. You can wait that long. You waited all this time. Yeah, well, you waited all this time. I think you can go another 5 minutes. All right, so we've got a couple angles. You've seen this situation before, but we're just going to describe. That's point N. This is M. This is K. And this is P. All right, so we've done this kind of thing before. But this is a little bit different. We're going to talk about things called adjacent angles. So everybody write this down. If your head's on the desk, get your head up and write this down. Okay, write it down. Just tap him. So we call these adjacent angles. So adjacent. So if I said to somebody, my neighbor, listen to me, my neighbor lives adjacent to me, or I sit adjacent to the person right next to me. Okay, what does that mean, adjacent to?
The person that's not directly in front of you, but to like the left or right.
Well, it could be directly in front of you. Adjacent just means right next to you. All right? It doesn't really mean across. It means just close to you. Very, very close to you. Okay? Everybody hear that? So, if I live adjacent to somebody, I'm usually talking about my next door neighbor. All right? If I live adjacent to them. All right? That's what it usually means. But in geometry, it kind of means the same thing. But let's take a look at what adjacent really means. I'll just read off the definition. It's in the book. But it's coplanar angles, so it means they're in the same plane, with a common side, but no common interior points. Let's write that down. They have a common side. So they're two angles that have a common side, but it doesn't stop there. There's two things that's true about it. So they're two angles that have a common side, but no common interior points. I'll show you what that means here in a sec. No common interior points. What in the world am I saying here? So let's take a look at what angles work on this. So what angles do you think are next to each other? I'll tell you what. I'm going to put a 1, a 2, and let's make this whole big angle. We'll call that 3. Is that all right? Just to make it easier for us, so we don't have to use all these letters. So which ones do you think are right next to each other? 3 is that whole entire thing. You understand that, right? 3 is from there to there. So 1 and 2 look like they're right next to each other. Let's go through these two things and see if it fits, see if it works. So do they have a common side? Look at angle 1 and 2. Do they have a side that's shared by both of them in common? Do they? Which one? Which side? And what? And it's just a point. It's not a side. The side of an angle is called a ray. So what ray is in common with angle 1 and angle 2? What's a ray? How do we... Come on. We spent a lot of time talking about how to describe a ray. How do we describe a ray? With 2 points, right? And then the first one has to be the end point. Okay? So, try it again. Is it M and K? Is that what you said? N. Right. N-K. Don't say N and K. Just say ray, what? N-K. Right? It's scaring me a little bit because we talked a lot about rays and how to name them. Right? This is why you need to know how to name stuff. So, what side is in common with ray, or with angles 1 and 2? Ray what? NK. That ray is in angle 1, isn't it? And that ray is in angle 2. Okay? So that means it's in common. In order for angles to be adjacent, they can't have any common interior points. So if I put a point in angle 1, is there anywhere that I could put a point in angle 1 that will also be in angle 2? No, there's not. I could put points anywhere I want in angle 1. There's no way they're going to be in angle 2. Agreed? So that means what's true about angle 1 and 2? Angle 1 and angle 2 are adjacent angles. What about angle 1 and angle 3?
No.
Let's take a look at that. Angle 1 and angle 3. Do they share a common side?
Yes.
Angle 1 is this one right here. Angle 3 is this big one. What's the common side that they share?
Right and the
No. And M. This one. They both share this side right there. But, listen. Are there any common interior points? Yes, look. All of these points right here. They're in angle 1, and they're also where? They're also where? In angle 3. Okay. So that's what that means. We still have a little bit more to do with that. So if you want to look at the homework, guys, listen to me. If you want to look at the homework and get as much of that done as you can, then you don't have as much homework tomorrow, okay? So get as much of it done as you can. We'll finish this lesson up tomorrow.